Welcome back. Now that we understand the broad paradigm shift away from linear automation, we can map the foundational concepts you already know directly to the architecture of LangGraph. Grasping a new architectural paradigm is easier when anchored to familiar UiPath features. Think of a standard sequence or flowchart. In LangGraph, this maps directly to graph execution, serving as the overarching canvas where your workflow runs. Next, consider arguments, the variables passing data between parts of your automation. In the LangGraph ecosystem, this maps directly to state management, acting as a persistent memory payload traveling with the execution. Finally, think about Action Center, where a robot waits for a human to review an exception. LangGraph replicates this vital function through checkpointers, saving the exact state of the graph at a specific moment and allowing execution to seamlessly resume later. Drawing these direct parallels makes agentic workflows much more approachable. When building an automation, your foundational building blocks dictate flexibility. In traditional platforms, you rely on activities, which execute rigid, pre-compiled functions strictly based on input variables provided at design time. If you drop a click activity onto your canvas, it does exactly that one thing. Nodes in LangGraph represent a leap in functional autonomy. While a node is still a unit of work, it executes dynamic functions capable of generating novel outputs based on the current state of the workflow. Instead of performing a mechanical task blindfolded, a node often houses a large language model that analyzes complex context and independently decides how to process data. A node acts more like an independent worker, evaluating the provided context to determine the best approach. This functional autonomy highlights the operational ceilings of standard flow decisions. Deterministic routing relies entirely on explicit Boolean logic and predefined operational thresholds. For a process to work, developers must engage in exhaustive manual mapping of all potential routing outcomes, anticipating every exception. When encountering an unmapped variable value, deterministic routing breaks, causing the process to fail. Furthermore, traditional linear flows lack the ability to self-correct during unexpected execution failures. If an application programming interface changes its response format overnight, an automated robot cannot pause, evaluate the new format, and try a different parsing strategy. This rigidity is why scaling traditional automation to handle unstructured business processes often leads to massive maintenance overhead. To overcome the fragility of rigid, rule-based systems, LangGraph introduces cognitive conditional branching, using reasoning to dynamically determine optimal execution paths. Instead of relying on hard-coded logic, a routing node evaluates the current comprehensive state of the workflow in real time. It autonomously infers the missing requirements needed to drive the task to completion. Once the node understands what is missing, it dynamically routes execution to the specific actor best equipped to resolve that gap. Imagine an automation handling customer support tickets. If a ticket involves a billing dispute, the routing node reasons that account history is required, dynamically fetching the ledger before routing to a financial node. This reasoning-driven approach manages unpredictability without nested conditions. Deploying the right tool requires developers to build a decision matrix for project scoping, evaluating predictability and variance. Your first step in this strategic application framework is assessing the structured nature of inbound enterprise data. If data arrives neatly in formatted spreadsheets, traditional tools remain highly effective. However, if inputs are messy vendor emails or conversational chat logs, agentic orchestration is required. Next, determine the necessity of cyclical revision versus straight-through processing. If a task requires generating a draft, reviewing it, and iterating before finalization, the cyclical nature of LangGraph is essential. Finally, evaluate the security and transactional requirements of target systems. Agentic workflows generate dynamic outputs, demanding strict guardrails for high-risk databases. Architectural selection requires aligning the platform with the fundamental nature of the required task. Mandate the use of UiPath for high-volume, deterministic user interface automation and deep integration with legacy systems lacking modern access points. When the process demands thousands of repetitive, rules-based clicks executed at high speed, traditional automation is unmatched. Conversely, leverage LangGraph for highly variable, unstructured data triage and complex cognitive reasoning workflows. When a business process requires understanding nuance, making judgment calls, or adapting to unpredictable inputs, Agentic Orchestration provides flexible intelligence standard robots lack. Successful developers view these platforms as highly complementary tools, forming a comprehensive, intelligent automation strategy. As we wrap up our foundational overview, let us consolidate the crucial concepts covered. Traditional robotic process automation relies heavily on deterministic, linear execution driven by directed acyclic graphs. LangGraph breaks these limitations by enabling the stateful, cyclical orchestration necessary for cognitive reasoning. We bridge the conceptual gap by mapping activities and arguments directly to LangGraph nodes and state management. Finally, architectural frameworks dictate deploying traditional tools for strict mechanical execution, and LangGraph for dynamic reasoning.